All right, last section of 5.7, using congruent triangles, CPCTC. We're going to be saying that a lot. Get used to it. It's kind of fun to say. CPCTC, CPCTC, CPCTC. All right, that's enough. Warm up. So some properties we've talked about before. If RU is congruent to WX, and WX is congruent to YZ, so these are the same, right? Then you can say these two are congruent also, and that's the transitive property. Remember, you give someone a cold, they give someone else a cold, you basically gave that other person a cold. Transitive, it transmitted, it moved along from one to the other. A is congruent to itself, that's reflexive, we use that a lot. And the B is the same as C and C is the same as B. We just flipped them. And that's symmetry. Okay, if something matches left to right, it's symmetrical. All right. So here it is, CPCTC. So this stands for corresponding parts of congruent triangles. I started to write a T. We already have a T. Are congruent. So far in this unit, we have been using rules like SSS and SAS and HL to prove, based on certain parts, that the triangles were congruent. Well, we're going to go one step further now. We're going to do the same thing. We're going to prove triangles are congruent to each other, like we have been doing. But then after that, if you notice, now we're not proving triangles congruent. That used to be the end game. The end game now is to go one step further, and once you have proven that triangles are congruent, then you can say any part of those triangles are congruent by CPCTC. And that's going to be our ending line. So the last two lines of any of these proofs are going to be the triangles are congruent by HL or SAS or SSS, something like that. And the last line will be this, and we'll say CPCTC. So let's do it. So we're given, based on this drawing, angle 1 is congruent to angle 2. We're also given that angle RTQ is congruent to angle RTS. So where is that? So let's mark these. So angle 1 is congruent to angle 2. And RTQ, which is right here, this angle, is congruent to RTS, which is this angle. All right? So we know the two angles that have been given to us right there. All right? Now we need to prove these triangles are congruent. So what do we always mark? Well, anytime we have a shared side like this, we can say RT is congruent to itself by the reflexive property. And look what we have. We have AS. We have proven the triangle is congruent. Okay? And we can just kind of copy this and just make it triangles, because RT is the same on both, and we go out to the Q and the S. So we just say triangle RTQ, order is important, is congruent to R triangle RTS. Okay? And we say that by AS. Now that we've proven the triangle is congruent, we can make pretty much any statement with the corresponding parts. So if you look at QT, that's this line right here, and ST, that's this line right here. We can now say that QT is congruent to ST, and we just say CPCTC. It really is fun to say. Hit pause if you need to. All right. So it says use the given information in the diagram to prove that A and C are congruent. All right. So notice we don't have any given statements here, but we do have things marked. So we can say that AD is congruent to CD. And remember, order matters. If we're starting from the outside here going towards D, we want to say CD, not DC. All right. Then AB is congruent to CB. That's all we're given. Not in a statement, but in markings. And then what do we always do? Well, we always take anything like this and say BD is congruent to itself by the reflexive property. And look how easy this is. We now can say that ADB, now remember we're going this way. Whoops. Did not mean to do that. If we're going A to D to B, right? So see how we're going down the 1 lane road or the mile marker 1? We're going to go CDB. So we say triangle ADB is congruent to triangle CDB. And by what rule? Side, side, side. And once we have that, once we've proven triangles congruent, we can say any of their corresponding parts. And remember that little trick. If I do ADB and CDB, well, what matches? Angle A, which corresponds to angle C, is congruent by CPCTC. All right. Let's write a proof. So we're given angle 1 is congruent to angle 2, and that's marked. Angle 3 is congruent to angle 4. That's given. Okay? So the reason that is this line here is obviously bisecting the two angles. All right? So we have two angles marked. And now we're going old school, and we're just trying to say that this triangle here is congruent to this triangle here. No CPCTC. We're stepping back and just proving triangles congruent. Well, I sort of fibbed because we actually are going to use CPCTC. This is going to be a more complicated one because we're going to prove two different triangles congruent. So the first thing we're going to do is prove this and this. Isn't that lovely? We're going to prove those two triangles congruent. Okay? So we know that AC is congruent to itself. So we can say AC is congruent to AC by the reflexive property. Okay? Now, what that means is if you look at this, we have angle, side, angle, and angle, side, angle here. So we can say that triangle CDA is congruent to triangle, follow with me, CBA by angle, side, angle. Now, once we know that those two triangles are congruent, and we do our little trick, CDA and CBA, look what we can say. Right here, CD is the same as CB, right? So we can say that now. We didn't know it before, but we can say that CD is congruent to CB by CPCTC. Now, on the smaller part, we have said that this is equal to this. We know 1 and 2 are the same. And then also, we can say CE is equal to itself by the reflexive property. And then look what we have here. We have side, angle, side. And we can prove that BCE is congruent to triangle DCE by side, angle, side. So what we did was we proved the bigger triangle congruent. Using that knowledge, we marked pieces of the smaller triangle congruent with CPCTC, and then we used the new pieces to use SAS on the smaller triangles. All right, so here you're just going to list the 5 ways of proving triangles congruent. You know, all those letters we mark, just list them out here.